What you're about to hear is not another cosmic exaggeration, not another overhyped mystery blown out of proportion. This time, scientists are genuinely worried. The James Webb Space Telescope has found something that doesn't fit into any model, any equation, or any timeline we've built to understand the universe. It's so bizarre that NASA researchers spent weeks trying to convince themselves it was simply an instrumental glitch. But the signal kept returning, clearer each time, forcing them to confront a reality they did not expect. Webb has detected an object, or perhaps a structure, that behaves as if the laws of physics are merely suggestions. The story begins with a faint distortion in a distant patch of the sky, billions of light years away, a place Webb was surveying for early galaxies. Instead of spotting normal cosmic features, gas clouds, protostars, or faint ancient galaxies, Webb registered a violent, recurring spike in energy that appeared to come from a single point. This wasn't a star. It wasn't a black hole. It wasn't even a supernova remnant. In fact, the emission had no known astrophysical fingerprint. It was too bright for its size, too organized for a random explosion, and far too stable to be anything chaotic. The deeper Webb looked, the stranger it became. The pulses of energy did not behave like any natural radiation pattern. They fluctuated in a rhythm, not periodic, not random, something in between, like a coded heartbeat of an object that shouldn't exist. When scientists plotted the pulse intervals, they noticed a disturbing alignment. The pattern matched multiples of several fundamental cosmic constants. That alone shouldn't be possible. Natural cosmic events don't choose numbers that appear in quantum physics textbooks, but this one did. Even stranger, the object's brightness appears to be increasing over time, which should be physically impossible for light that left the source billions of years ago. The only explanation, whatever this thing is, it's interacting with space-time in a way that allows its effects to propagate across unimaginable distances. It's as if the universe itself is reacting to its presence. And now, scientists are asking the question no one ever expected to ask. What if this isn't a thing? What if this is a process, something that has started, something we've never seen before, something the universe has been hiding until now?
When NASA assembled a cross-disciplinary task group to investigate the phenomenon, the first hypothesis was extreme lensing. Maybe a cluster of invisible mass was bending distant light so dramatically that it created an illusion. But the gravitational lensing didn't match any known profile. Instead of smoothly stretching background galaxies, the distortion formed swirling arcs as if sculpted by a rotating field of immense, uneven gravity. That alone was unusual. But then came the real shock. The anomaly seemed to be surrounded by a halo of compact, invisible masses orbiting it. Webb couldn't detect the objects directly, but their gravitational signatures left faint but unmistakable ripples. These ripples were too sharp to be dark matter, too organized to be natural debris, and too stable to be random. Some scientists proposed that they could be the remnants of collapsed primordial objects, exotic structures from the first instance after the Big Bang. Others suggested the halo might be a gravitational echo, a kind of standing wave in space-time created by something much larger and much stranger. But the most unsettling possibility came from analyzing the object's spectral fingerprint. Instead of the expected chaotic spread of wavelengths, the emission spectrum showed clustered bands, tight, narrow, and precisely aligned. Nothing natural produces that. Not quasars, not magnetars, not even theoretical exotic stars. This was something else. When the team ran simulations, one idea kept appearing. The object might be an ultra-dense region of pre-baryonic matter, the kind that existed only before atoms formed. If that is true, then the anomaly is not just old, it is older than everything. A piece of the universe frozen in a state that should have disappeared forever. But if that were the case, it should be stable, inert, undetectable. Instead, it's pulsing. Every pulse resonates across space like a ripple on a cosmic ocean. Every pulse slightly alters the gravitational field around it, and every pulse seems to contain mathematical structure. One researcher described it this way: it's as if the object is not just releasing energy, it's releasing information. Not because it's intelligent, though that possibility can't be fully dismissed, but because the physics inside it is so exotic that energy, mass, and information become indistinguishable. The deeper scientists dig, the more it becomes clear. This is not simply an object. It is a phenomenon that appears to be evolving.
What happens when something in the universe evolves faster than we can explain it? That's the question gripping NASA now. A comparison between early Webb data and the latest observations revealed something chilling. The pulses are slowing down. Not much, just a fraction of a percent. But the difference is real, measurable, and unmistakable. Something inside the anomaly is losing energy. But the energy isn't radiating outward. It's disappearing, as if being absorbed into a region of space-time that we cannot see. Theories range from exotic to terrifying. One suggests the anomaly may be collapsing into a higher dimensional structure, leaking energy into dimensions beyond our own. Another proposes that it's undergoing a phase transition, like ice turning to water, shifting from one state of matter to another, one that has no counterpart in our universe. But the most controversial idea is that the anomaly is acting like a gravitational engine, pulling in mass, converting it into structured pulses, and radiating only a portion back into our universe. This would explain the strange halo of compact masses orbiting it, drawn toward the anomaly but never falling in fully, trapped in a gravitational dance that defies equations. As Webb zoomed deeper into the region, something else emerged: micro-lensing events, tiny flickers in starlight that indicated objects passing in front of distant stars. Except the flickers happened too quickly and too precisely. Whatever is orbiting the anomaly is small, dense, and numerous. Could they be fragments of the anomaly itself? Could the structure be shedding pieces as it shifts into a new state? Or worse, could it be assembling something? A pattern hidden in the halo suggests a strange symmetry, not exact, but consistent enough to raise eyebrows. The orbital paths of the compact masses appear to be aligning over time, not randomly, not chaotically, purposefully. It might be natural, driven by an internal gravitational mechanism we don't understand, or it might be something much more complex, the emergence of a cosmic-scale structure forming around the anomaly, like rings forming around a planet or petals forming around a flower made of gravity and light. Whatever the cause, one thing is certain: this region is no longer passive, it's active. And what comes next may redefine everything we think we know about cosmic evolution.
NASA's final report, at least the part made public, admits something unprecedented. The anomaly is entering a new stage. The pulses are merging, creating larger but slower waves. The halo objects are drifting into more synchronized orbits, and the distortion of background galaxies is intensifying, suggesting the gravitational field is not only changing but expanding. This expansion is the part scientists fear most. If the anomaly is growing in influence, even subtly, then we're witnessing a process rare enough to reshape cosmology. A collapsing exotic object? A forming space-time defect? A dimensional fracture? No model fits perfectly. But the energy deficit raises a disturbing possibility.
The anomaly might be drawing mass or information from outside our observable universe. Not in the science fiction sense of a portal, but in the very real sense that space-time can, under extreme conditions, couple to regions beyond our cosmic horizon. If that's what's happening, then Webb may be watching the first known example of a universe-scale feedback loop, energy leaving our universe while something else replaces it. And then came the most unexpected result. A new gravitational map revealed a faint but enormous curvature surrounding the anomaly, far larger than previously thought. It resembles a bubble, a boundary, not empty, but consistent with a colossal reservoir of invisible mass. A dark mass structure with no stars, no gas, and no light. A ghost galaxy. And the anomaly sits perfectly centered inside it. Could it be controlling the structure, feeding on it, awakening something dormant at the core of a long-dead cosmic formation? None of these ideas should be possible, yet the data refuses to agree with anything simpler. For now, scientists can't explain what Webb has detected, and that uncertainty is spreading through every corner of the astrophysics community. Because if the anomaly continues to evolve, if the pulses continue to slow, if the gravitational field continues to expand, then we may be watching the early stages of a cosmic event that has never happened in our universe's history. And the most haunting part is this: the anomaly is billions of light years away, which means whatever is happening already happened. And the version we're seeing now might be only the first whisper of something much bigger still on its way.